how long is it going to take this ball to hit the ground when this man throws this ball vertically downwards with an initial speed of 3.0 meters per second, and this ball travels a vertical height of 4.0 meters. This is a problem on kinematics, and one of the kinematics equation we use to calculate the time it takes an object to hit the ground is delta y is equal to 1/2 gt squared plus v naught t. In the case where v naught is equal to 0, that is when this ball is just dropped without giving an initial velocity, then the time it takes to hit the ground is always given as t is equal to the square root of 2 times the vertical height divided by the acceleration due to gravity. However, in this problem, this ball is dropped with some initial speed which is pointing vertically downwards. So choosing our coordinates, we are going to choose that vertically downward is negative and then upward is positive. So this is a purely vertical motion, so we don't have any horizontal motion. So we cannot use this equation to find the time it took this ball to hit the ground, and the only difference is that now we have delta y is equal to 1/2 gt squared plus v naught t. This term doesn't go to 0 because the v naught is given to us as 3.0 meters per second and it is pointing downwards, so that is going to be negative. The displacement, also delta y, is going to be negative because it is pointing downwards. We are going to take acceleration due to gravity, which is also pointing downwards, to be negative 10 meters per second squared. So let's look at how to solve this problem step by step. So delta y pointing downwards is going to be negative 4.0 is equal to 1/2, and then g, which is also negative, so negative 10 meters per second squared, and then the time t squared plus. Now v naught is also pointing downwards, so that is also going to be negative 3 times t. So this is the equation we have and we need to simplify. So here we are going to have negative 4.0 is equal to, so 1/2 of negative 10 is negative 5 t squared, and then this is negative 3t. Now if you look at this equation closely, we can rearrange it such that if I move the negative 5 to the left hand side, it's going to be positive 5t squared, and if I move the negative 3t, it's going to be positive 3t, and then we already have negative 4.0, so we have minus 4, and that is equal to 0. And this is a quadratic equation. So this equation is in the form a t squared plus bt plus c is equal to 0. And in this case, our a is going to be 5, our b is going to be 3, and then our c is going to be negative 4. And we can solve this either by factorization or by using the quadratic formula. I'll choose the quadratic formula, which is given as time is going to be negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So now we can plug in the values in and then we can find the value for the time t. So the time is going to be t is equal to, so we have negative b and b is 3, so we have minus 3 plus or minus, that means we are going to have two solutions for the time, and then we have square root of b squared, so 3 squared minus 4, and then ac, a is 5 and c is negative 4, right? So we have times 5 times minus 4. So all this divided by 2a, so 2 times 5 is going to be 10. We can further simplify this, so we are going to have the time to be equal to minus 3 plus or minus square root of, if we evaluate all of this in the bracket, we are going to have 9, and then this negative times that negative will be plus, and then all of that is going to give us 89, and then divided by 10. So solving this, we use negative 3 plus the square root of 89 divided by 10 will give us the first time to be t1, which is going to be 0.64 seconds, or we are going to have t2, which is going to be negative 3 okay, minus, that's the second solution, square root of 89 divided by 10. That is going to give us negative 1.2 seconds. Okay, but physically we don't have negative time, so the correct answer is going to be 0.64 seconds. I hope you found this helpful, and if you did, like, share, and also follow for more of such videos. Until then, I'll see you on the next one. Bye bye.